Oh, hello. Didn't see you there. All right, so we're doing some live coding. This is a mashup. I believe this was Sydney and Tiffany recommending this one. Thank you very much. What we are doing is writing a function that takes an array of numbers and a target number. It should find two different items in the array that when added together give the target value. The indices of these items should then be returned in a tuple. So this is like, I'd say pretty indicative of like kind of thing you do on a coding challenge. Sydney's request was that I do it in a language that I don't know. I have written probably less than 100 lines of Python in my life. So we are doing this in Python. Cool. Questions before we begin?
Actually, yeah. What's the first thought about like how you would, like your first instinct tackling something you don't know?
Sure. Draw pictures. As you will see. Other questions? No, my first instinct is panic. All right, let's dig in. So I'm going to open up a whiteboard. Oh no, do not look behind the wizard's curtain. All right. So step one of the Polya four-step process is clarify the what and the why. So what are they asking me to do? Like what's the black box on this? So it's going to take an array of numbers and a target number as the input. And 4. So those are the inputs. The indices of these items should then be returned in a tuple. So tuple, we don't use that word a ton around here, but a tuple is an array where the positions are significant. So like in this input array, there's nothing special about position 0 versus position 2. They're all basically the same thing. That's an array. Like in technical terms, an array is something where everything is of the same data type, and the order matters, but past that, they all serve kind of the same purpose. If the order doesn't matter, it's a list. And if the positions are significant, like the first position is the first name, and the second position is the last name, and the other one's the company, that's a tuple. So we want out from this is if we got that, it'd be position 0 and position 2. So we'd get back that tuple. Okay, so that's what they're asking us to do. And then inside the box, find two different items that sum. Okay, so some other like clarifying what and why on this is from the language of that, I can tell it can't be the same. So if it was 1, 2, 3, so like I couldn't do 2 twice. Oh, actually, hang on. It could be the same number if they said 2 different items. So an item in an array isn't really the same as number. Although, since we're in an interview, I want to make sure I have my vocab right. I thought an item is a part of a list. I'm almost positive like part of an array is an element.
That's right. For Python?
Well, just like in general.
I thought item in Python refers to like a key value pair.
An array consisting of elements. Your boy got it. If we do list data structure, first component. So it doesn't look like they have like a fixed name. All right, fair enough. All right, so it can't be the same element twice. We also got from the prompt that you can have multiple correct answers. And input will always be valid. So that means I don't need to check for, did they try to slip a string in, something like that. And that it also says it will always be solvable. Okay, cool. So I think I like kind of have my head around this problem a little bit. So takes these two things, figures out some match of these that equal the target number. That's what's happening in the box. And I need to return these element positions when I'm done. It's never going to be the same element twice. It's always solvable. I'm always getting valid input, and there might be more than one correct answer. All right, I think I understand the problem pretty well now. So last thing, I'm going to figure out what I would test. So like this one's a pretty decent one. Actually, let's see if I can do an even easier one than that. Oh, it also said in the prompt, I think you always get at least 2. Yeah, numbers will always be an array of 2 or greater. Always more than one input size. All right, so the like easiest one would probably be something like 4, 0, and 4. And in that case, the answer would be 0 and 1. Next case might be something like, it should probably also work if there's more than one thing in there. So that should either return 0 or 1 or 0 or 2. If it's actually doing some adding, I could say 1, 1, and 1, and 2. So that could be 0 and 1, or 0 or 3. Nope, 2. Or 1 and 2. All right, so if it can do, I'm going to put one more case in here. I'll put the one they gave us. If it's 1, 2, and 3, and 4, then the correct answer is 0 and 2. All right, so that's how I'll know that I'm done when I've done that. Okay, that was step 1 of the Poly problem solving process. If I was doing this in an interview, I would do it exactly the way that I just did, narrating that the entire time. That's the party trick. That doesn't have anything to do with being a good programmer. Being a teacher certainly fucking helps. But like thinking through a problem in your head while explaining it out loud is a very like 2 things at once kind of skill. The way that you get better at it is by doing it a lot. You can be a killer programmer and not be able to do that. It's one of the reasons whiteboarding interviews are such a shitty, lossy interviewing technique. Doesn't mean it's not going to happen to you though. So it's worth developing the skill.
What did you call the process?
Polya's 4-step problem-solving process, named after Georg Polya. Other questions about step 1? Cool. So step 2 is enumerate some solution ideas. So some solution ideas, really what we want are different permutations of all the things in the input. And that's actually really common. It's shockingly common in interview questions and very uncommon in real life is just generating a whole bunch of permutations of like a list. But that's probably going to be a good starting place for us. So like get all of the different permutations. Now, since the ultimate thing that we want is the indices, like that makes a little bit of sense that, yeah, like those are the permutations you want. You want not the actual permutations of the items, although or the elements, that certainly helps too. But we really care about different permutations of the indices. So like the smallest one we could possibly get has those two things. So our permutations are 0, 0 and 1, and that's it. Like 1 and 0 is not a different one. So if there's 3 different positions, then we have 0 and 1, 0 and 2, 1 and 2. If we have 4 different positions, it's all the ones from before. Actually, 0 plus 3, and then 1 plus 2, 1 plus 3, and then 2 plus 3. They get all of them? 0 and 3, 0, 1, 0, 2, 0, 3. That would be 0, 1. This would be 0, 3. I already have that one. Or yeah. This one would be, okay, cool. I think that's all of them. So, all right. So now I'm starting to get a sense of like how those permutations might work. We've got like, you maybe do that recursively. I don't know if you can do recursive functions in Python. Maybe not. We'll see. But like, that's the first thing that says to me is like, maybe that could be done recursively. Any problem that's like this, where it just gets smaller towards some end value, that's like instant alarm bell, might be a recursive solution. Okay, so I would need to do something like that. And then once I have those, like, so if I've got all 6 of these, I would like iterate through each of those. And it doesn't say it wants every match, just any valid one. So we could say something like, I was going to say like just actually do the calculation on each of them and then like return any match or return the first index of a match or something. It's actually probably going to be more efficient to do like a while. So maybe that would be like a while. While, what would that be? Something equals like the target.
You could do
While sum is like isn't the target. Then you do whatever else. So while the sum isn't the target, then you keep like iterating through, and then the sum equals sum this thing. And then since we're like we can take a couple shortcuts here. Since we know that it's always going to be solvable and that the input is always going to be valid and stuff, there's a couple things that we don't need to check for anymore. And so like whenever that happens, we could say like, all right, if the sum equals this, break, if sum is target, break, and then, or even better, return those indices. All right, so that's step 2 of the problem solving process, is like enumerate some ideas, come up with a plan, and yeah. Questions about step 2 of the 4-step process?
Could you specifically define exactly what a permutation is?
Permutation is like, actually, these might even be permutations. These might be combinations. I always get them mixed up. Let's see, permutation versus combination. In permutations, we care about the order of the elements. As combinations, we don't. Let's see. Definition of permutation. A way, especially one of several possible variations, in which a set of numbers of things can be ordered or arranged. There you go. Other questions about step 2?
Should you enumerate multiple ideas?
Let's see. So like some different ideas that I had would be,
I mean, from the problem solving perspective.
like I talked about how I could find every match and then like just return the first element. Talked about, well, shoot, since I only need one, I could while through it and just return the first thing that I find off of that, instead of like iterating through all of them first. And so I would pick this one because it's more efficient. So that's technically 2 different possible solutions, and I picked a more promising one. I could probably come up with more.
Do you need the return statement in there since if you're doing a while?
I don't even know if I'm allowed to in Python.
You can force a return.
Cool. I guess I'm about to find that out. But just from a logic standpoint, I want to break out of the loop at that point and return whatever the current things were.
Okay, thank you.
Other questions? So yeah, what I did here, that's not Python. It's not JavaScript. It's not C. Just logic. It's kind of sloppy. It's just get my ideas out of my head and in front of me. All right. So step 3 is working the problem. So go over here. Python. See, do I have Python installed? I do. Lucky me. I need to make something to work in. I don't know what's conventional on this. Maybe app.py. Sounds about right. Can I run Python app.py? Apparently I can. I like it. So whenever I'm working in a language that I don't really know anything about, I'll go to learnxandYminutes.com. This is like a Rosetta Stone for programming languages. Oh, that's right. I know there's a Python 2 and 3, and I never know which version I have. It's like they're both kind of in use still. Python version 2. See, there you go. Glad I checked. All right. So I look through this.
Hey Kyle, are
Yep.
there some websites that are like really widely known when it comes to like stuff like interviewing? Because I thought before in these we've been told that like it's always best to like go to the docs first,
Mhm.
or are like do enough people know about Learn X and Y minutes that like this is considered like kind of gospel along the same lines as the docs?
Learn X and Y minutes is probably more of like a hidden treasure than like a commonly known thing. And it's really useful for things like programming languages, because programming languages ultimately aren't that fucking different. You can do the same things pretty much in all of them. So that's why it works so well as a Rosetta Stone, is because it's pretty much all this same stuff in every different language. That's different than Rails or Django or ML5 or D3 or something like that, where they're all solving pretty different problems. All of these are solving the same problem. So that's usually why I start here.
Okay, thanks.
Okay, so looks like it does division the same way that Ruby does. It's got we got a floating point stuff. It's also looking like it's not, you don't explicitly type anything. All right, we use the and keyword and an or keyword. It looks like true and false are with capital letters. Zero's falsy, good to know. We use not to negate. Double equals for equality, bang equals for inequality. Oh, that's kind of cool. Strings work same as JavaScript. That's fucked. I hate when languages do this. Cool. They do these template strings. Those are kind of common in non-JS languages. We use is when we're working with objects. I don't think we're going to, which is good. Print. All right, there's something we can start with right away. So if I open up something like that, can I run that and have it do something? Yay, cool. We're in flavor country. Okay, so looks like we do, they're calling them lists, which makes me think there might be a separate thing for array, but this will probably work for us. We have append and pop. That's good to know. Most languages, this would be push and pop. can access stuff by index. I love this. This is one that drives me nuts when a language doesn't have it.
Wait, quick
Ooh,
question.
yeah.
With strongly typed languages, is that the normal, I guess, default for arrays? Because it's like that in Dart too.
No, it's a different data structure. It's more general. Like an array is everything is the same type and the order is significant. Like in JavaScript, we just use the term way more generically, but that is a technical definition of an array.
Oh, okay.
It's cool. We can get like a slice of an array. That's how we remove stuff. That's cool. You can concatenate lists like that. Good, good. Oh, that's nice. Okay, that one's going to come in handy. So we've got this len that we can pass something into to get the length of a list. Oh, there's an actual tuple data type. Cool. But otherwise work the same as lists. Probably not going to use those. Although it's really cool that you can do set math. That's baller. All right, control flow. Here's something we care about. If, elif, else, all right? And the if opens with a colon. This is like the one thing that I know about Python is it's a white space significant language, which is stupid, but whatever. They didn't ask me. That's how we loop. We can use this range thing. Oh, that's kind of cool to do it like a specific number of times. All right, and we do have whiles. All right, last thing I need to know is functions. There we go. Def, add, colon, return, and calling it. All right, I feel like I have enough to at least get started on this. And so I will. So first thing I want to do is like, I don't know how to write tests in Python. And if I'm in an interview, I'm probably not going to start learning. But I can still recreate something kind of like this. So if I make this function, I call it def add. I already forgot that. Okay, so they use same kind of convention as Ruby with snake casing. And this is called toSum. And it's going to take in a list. So the fact that that highlighted when I did that tells me that's probably a keyword. So call that number list and target. Takes parentheses around it. And it returns, I'm going to like hard code in a tuple for right now. I'll say it returns 0 and 1. And then for these tests, if I don't like want to take some time and figure out a testing framework, you can always do shit like this. Where you say something like print toSum, and then what did I have? 4 and 0 and 4. And then maybe something like this should be 0 and 1. Maybe something kind of like that. So then when we actually run this file, oops, we should see something like that. Serves the same function as a test. It just gives us instant feedback on whether or not we did this right. Cool. So my other test cases were 4, 0, 0, and 4, and 1, 1, 1, and 1, 2, 3. That one's 2. So that one should be 0 or 1 or 0 or 2. Or 0, 2. Or 1, 2. And this one should be 0 and 2. Cool. So got my test cases set up. Awesome. Ooh, and actually, I can also do the comparison in there. So I could say something like, shoot. Nah, fuck it. That's too far. I was going to say I could actually just do the comparison and see if they all return true or something like that. But since I have a few different options here, fuck it for right now. All right, neat. Now I want to start like doing my strategy. So the first thing that I wanted to do was come up with a bunch of permutations. So I'm going to make that a separate function, get permutations. And that takes in a number list. And all right, now I need to figure out what I would actually like expect that to bring back. So if I did something like, how do I do comments in this? Pound. So if I did something like that, or what I would expect to get back is what I expected. Somebody saying something?
I think I didn't realize my microphone was on that whole time. That was just a Slack notification. My apologies.
Your apology is accepted, Jonathan. Okay, so maybe what I want to get back from this is like an array of arrays, something like that. So that should be 0 and 1. And if I did that, I want 0, 1, 0, 2, 1, 2. All right, so now I need to figure out how to make that happen. So this does not actually have anything to do with the contents of it, really just the length of the list. So I had that len function. Is that all I need to do to declare a variable? Yep. Length equals len number list. All right, so like on that first one, that first example, that should give me like 1. And then now I got to think about how I would calculate what all those different permutations would be. So I could take, fuck, I'm so bad at these things. if I take the first, I start drawing. So yeah, that question at the beginning, what do you do when you get, when you're like starting a problem? So this decomposes down, right? Really, I'm doing like this four-step polygon process again, just with a smaller problem. And my first instinct is like, all right, just start drawing pictures. So I've got this. I thought about this in terms of length of the array. It's a 2, a 3, and a 4. Another way I could think of those, look at that 3, 1. I could say I want this one and this one, and then that one. Okay, now I'm starting to get an idea. And then for that 4, 1, that's with that one and that one and that one, and then that one and that one, and then that one. All right, all right. So now I gotta like figure out what the pattern on this is. And it's really like, start with the first element. And then generate pairs with each remaining element. And then, okay, so this is that like recursive thing. Then I want to do that exact same thing with just a shorter list. Oh shit, that slice syntax might actually work pretty good for this. So first thing I want to check, Python, are you allowed to use recursive functions? Hey, cool. Looks like that is allowed. So that would be, okay, so really if I solve this first problem, then that gives me like the first item in like my ultimate list. Then all I need to do is call that function again with a slightly smaller list, this guy. So this get permutations thing is going to be like get combos for first item, and then return those. Ooh. And then return the something like that thing, and then like get permutations rest of the list, like something kind of like that. All right, so this first problem, get the combos for the first item. So I have this length of the number list. I want to, so like for this first one, the length is 1. Oh no, sorry, the length was 2 for this first one. So I want the first element and the second element. Actually, this might be easier to think of with the next one. If it's 3, this list is something like that. Oh, wait, my recursive thing, I don't think that's going to work actually. Because the reason that's not going to work is these permutations, I can't send it progressively smaller lists, not really, because it needs to know what I'm getting indexes. It needs to be the indexes of what the original array were. So I can't keep slicing the array smaller and smaller. All right, that's why I was having a hard time with that one. All right. Now I'm thinking maybe I need to do a loop with that length. So I could say something like for, let's see what the syntax was. For I in range. There we go. For I in range lengths, like that. Right? Yeah. Okay, so for every one of these, I'll say the result starts out as this empty array. In the first iteration, I is going to be 0? No. I in range for, no, it is 0. Cool. I is going to be 0. And it's going to count 0, 1, 2. Yeah. So I want 0. Result dot append I and maybe I plus 1. I think about what that would do. So for this first one, the length is 2. So I'm iterating 0 and 1. So I'm going to add a new array with 0 and 0 plus 1. All right, so it works for that first one. There's something. And then, okay, for the next one, it's going to go add 0 and 1, and then I is going to become 1. It's going okay so far. And then it's going to append 1 and 2. Okay, that's the rub. It needs to keep going. So I got the first one. I got this and this, but it didn't do that one. So it needs to keep appending I and then whatever the next number is, like up to that length. So that's going to be something like for J in range. And they had like, there we go, like that. So it'd be something like of range J through length. Yeah. So then we're going to append I and J. All right. All right. And then I return the result. Cool. I think that might do it actually. Let's check. So I can write a test for that. I can say print get permutations 0 and 1. This should be 0, and 1. Oops, nope, that was 1 and 2. And this one was 1, 2, 3. Should be 0 and 2, and 1 and 2. All right, let me see what that does. Oop, somebody didn't like. Local variable J referenced before assignment. Am I not? Oh, that's I. Okay, good. Oop. Something wasn't good about that. Oh, maybe it's it has to be like I plus 1, maybe. Let me try that. Hey, it worked. Cool, I like it. All right, so my permutations are popping. So now I need to take each of the things in those permutations. So I like permutations is get permutations number list. All right, now I want to, we said this strategy was I was going to while through those permutations. And I need to do something where like I'm checking that sum against the target, and as soon as I find a match, then I return. I'll bet I can return out of the for loop though. That might be easier. So I could say something like for permutation in permutations, if, let me check the if syntax. Did it use parentheses? There we go. It did not. All right. If permutation at 0 plus permutation at 1 equals target, return. Oh, but my permutations are in arrays, and I ultimately need to return a tuple. I wonder if I can't. I might be able to just tuple these right now. Like that. I'll bet I can do that. So then those change a little bit. Vim, baby! Vim, baby! Look at that shit. God, I love this text editor. All right, then I might be able to just return the permutation. And I don't even need to put like a guard or anything against it like running out of the list because I'm guaranteed that one of these is a match. All right, wonder if it works. None. It worked on this one though. Weird. Okay, so now I kind of want to see what's happening in here. So I'm going to add a print statement with permutation at 0, permutation at 1. All right. Oops. Okay. Oh, shoot. I don't want the actual indexes. I want the indexes from the original list. This guy, smart guy. So this is actually number list at whatever. Number list at whatever. That. All right, let me see if that works. Valid, 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 valid. Booyah, achieved. Okay, so I have a working solution now. That is step 3 in this process. So last step in the 4-step process is reflection. Let's like really take a good look at this answer. Let's figure out if there's any other assumptions that we're making or ways that we can make this code better. Now that I have tests for these, I don't want those anymore. Don't care about that anymore. Okay. Is there anything that I would do to improve this code? So I can get rid of my little placeholder comments. I don't like that I used single letter variables here, even though it is abstract, even though like I am working with indexes. I don't actually care what's in the list. Even still, I wonder if there's a more descriptive term I could come up with for this. Like starting index. I'm going to call that like a pivot index. Okay, so that was I. Pivot index. I'm going to call this like a stretch index. All right. That feels like a better one. Yeah. All right. Length and result. So like my next thought was like, maybe I rip out length, but I am using it twice. Okay, that's pretty good. All right, this one. That's good. That's good. I really don't like that line of code. So I'm going to say like first number. And then second number. Like that. And then I can do first number plus second number like that. And now I sort of want to call this target number so that it has some symmetry to it. Cool. So some other thoughts on this were like, I could probably improve the code by adding some like error handling. Oh, actually, shit, I changed a bunch of stuff and I didn't check if it still works. It's okay in my book. One more thing I might do is like a wild one. So if I had something, if I'm trying to get 100 and I have 27 and like 73, but all kinds of other stuff around them, maybe not necessarily in order. I got some other repeats in there, 20, 15. So like the right answer to this is 0, 1, 2 is the first one. 2, 3, 4, 5, 6, 7. So I should see 2 and 7 come back from that. Hey, cool, work. Adding error handling to that, like checking the actual values that I'm getting legal values. That would improve the quality of the code. But otherwise, I feel all right about this one. Efficiency. This really probably isn't that bad. The one thing that I could do that might improve the efficiency on it is instead of getting all the permutations and then checking them, if I sort of inline this so that you checked each permutation as you were going, that'd be more efficient. And then last part of the 4-step process, how about I look over the actual question that was being asked and see if I actually solved it. Write a function that takes an array of numbers and a target number. Done. It should find 2 different items in the array that, when added together, give the target value. Check. The indices of these items should be returned in a tuple like so. Check. For purposes of this kata, some tests may have multiple answers. Cool. I can handle that. Input will always be valid. All the items will be numbers. Target will always be the sum of 2 different items in that array. Cool. I'm going to go ahead and call this one solved. Mic drop. Cool. Ask me some questions.
One of my questions was when you made your get permutations function, that loops through everything. Would that affect time complexity negatively?
So yeah, that's actually when in my analysis where I was like, yeah, if we actually did the addition and the check in line, that would help. That doesn't actually change the time complexity though. So time complexity has to deal with how does it change as it grows. So right now, this is like O of 2n. The coefficient doesn't matter though. It can be O of 500n. What we're concerned about with big O is how does the processing time of the space change as the input increases? And like whether it's O of 1n or O of 5000n, it's still linear. So
in regards to like O of n, how would you, so does it not change time complexity? Like, because in theory, like it could run through and on the first iteration get it, and then it literally could get it on the very first 4 in break.
Right.
Would that, like, does that affect time complexity, or is that just, oh, this thing shoots out an answer quick per chance?
So like in a full analysis of time complexity, you would do worst case scenario, best case scenario, and average case scenario. So like thinking about the problems that we had, the best case scenario is you find it on the first one every time. And so like, I guess that would be O of 1 in the best case. In the worst case scenario, it's always the last one. And so you had to iterate through the entire list. That'd be O of n. Actually, I don't even know if the first one even counts as a constant time. That might also be an O of n. And then in general, you'd expect it to be somewhere kind of in the middle. That's probably still O of n.
Interesting. Thank you.
Other questions about anything I just did? I'll look through the chat. Some hummus talk. Strawberries. All right, cool. Hopefully that was helpful to see that process modeled. I'm feeling very blessed that I actually got through that. I get all stumbly every time permutations come up. Survey's coming out soon. Thanks much.